So regions of the Earth's atmosphere are shown here. And we'll look at this, kind of break down more of the information in a worksheet. But this is on the x-axis, the temperature in degrees Celsius. And this is going from negative degrees Celsius up to positive degrees Celsius. The y-axis is, though, this one. What is important to look at is these are the regions of Earth's atmosphere starting from, this is at 0 kilometers of altitude. Okay, so that's kilometers, should be km like this. And this is the surface of Earth where we live. So the region where we live, the lowest region of Earth's atmosphere and where we live is called the troposphere. That's down here from 0 to 11 kilometers. Okay, so this is called the troposphere. And 75% of the air of the whole atmosphere, which includes everything out to outer space, 75% of the air is down here in the troposphere. Okay, so, and that's because of mass and gravity getting pulled down. So there are particles that we cannot see in the air, and but they do have some mass to them. Okay, and are affected by gravity. So the good thing is this is where we need the air, down here in the troposphere, because this is where we live. So the troposphere has the ideal conditions for life. It has oxygen. And remember, oxygen is not just O, but it is a diatomic molecule. It is a molecular element in classifying matter. There are a handful of elements on the periodic table that are molecular elements, and oxygen is one of them. It's always present in nature as O2. Okay, never O. The oxygen molecule we need for combustion reactions. We need it to breathe. Fires need oxygen for combustion. Plants need need oxygen, or plants don't need oxygen. Not only humans need oxygen, but also all living things on the planet mostly do require oxygen. And so the oxygen is important to humans because we need it for combustion reactions involving digestion to provide us with energy. So digestion of sugars in metabolism we'll get to in a much later chapter, chapter 11. And so the troposphere has that oxygen we need. And also important to note of the troposphere is that the troposphere has this temperature range. This is this red here. And the temperature range in the troposphere has the smallest range. It's from negative 52. That's negative 52 degrees Celsius to about 0 degrees Celsius. That's in here. So this is negative 52 to 0 on the x-axis, and that's in the troposphere. So that's the smallest temperature range, and even within a smaller area we'll talk about, the warmest air is usually at the ground level at 0, and the air gets colder as you move up to higher altitudes. And this is something that you guys may have noticed if you ever go up into the mountains. There's cooler temperatures up there, unless the air is subject to air inversion. So air inversion is usually due to geography, and it does happen, particularly in the valley around Riverside. There's air inversion there, and that causes air pollution to get trapped. We'll get more into that. So this is the next layer up is the stratosphere. The stratosphere we'll be talking about quite a bit in the next chapter because it contains the ozone layer. Now, ozone has the chemical symbol O3. And ozone is something that is an air pollutant when it's in the troposphere, but when it's up here in the stratosphere, it actually protects us from harmful UV radiation. So ozone is variable in terms of if someone asked you, is ozone good or bad? And we'll get into the bad ozone. When it's in the troposphere, it is an air pollutant, but it's good ozone when it's in the ozone layer. It protects us. So the next layer up is the mesosphere, and the mesosphere is, so in this range, 48 to 95 kilometers. You have shooting stars burn off here. And the thermosphere is the next layer up. That's 95 to 550. And then outer space and beyond is called the exosphere. So you can see there are temperature ranges. This thermosphere, I'll point out, is the largest temperature range from -93 to 1,727. So large temperature fluctuations up there. And in general, though, we humans only stay down here in the troposphere. So though there are all these other regions, humans stay in the troposphere. Even if you go to the tallest mountain, if you go to the top of Mount Everest, Kilimanjaro, you'll still be in the troposphere. Okay? Even if you're on an airplane, you're still going to be in the troposphere. Most of us do not experience those upper regions unless you're going to become an astronaut. And if you are, then email me and say hi, I'm out in outer space. So the air we breathe, what's in the air we breathe? So no matter what day or where you live, the air contains this mixture, which is mostly nitrogen. So nitrogen is one of the diatomic elements. It is a molecular element. It's one of the handful of molecular elements. The majority of elements on the periodic table are atomic elements. So it's present in nature as N2. So that's not just nitrogen, but it's N2. And this is oxygen, also diatomic, so that's O2. So this is N2. Is 78% of the air you breathe is nitrogen. And that is not anything our body uses. It's neither good nor bad. What our body does need is that 21% oxygen. Okay, so when you have there's also other gases. So the majority of the air is nitrogen that is harmless. The oxygen is the O2 that we need for life. And then these other gases, what we're going to focus on in this chapter. So the highest amount of the other gases is argon. Argon is the noble gas, Ar. This is a harmless noble gas. It's just naturally present, and it doesn't do anything to us. Okay. Then there's carbon dioxide. So this is carbon dioxide, CO2. We all exhale that, and we're going to be getting into this quite a bit, is the concentrations of carbon dioxide, which are about 0.04%. It's a very low concentration when you compare it to the nitrogen and the oxygen, and even argon, which is 0.9%. But this amount is increasing, and it has been increasing for about 200 years, and it's leading to global warming and climate change. And then there's water vapor. So H2O is water vapor, and that's variable. So not just water that's liquid water, but water vapor that is a gas in the atmosphere. So water vapor depends on humidity, like rainfall, clouds, or fog. And it is variable based on the day and the location. And then what we're going to be getting into is the way less than 1% remainder are air pollutants. So air is a homogeneous mixture. A homogeneous mixture is a uniform composition, and you can't see the parts. Okay? So this compares to a heterogeneous mixture where you can see the parts. But air, we can't see all these. We can't see the nitrogens from the oxygen from those other gases. And so a mixture has to have 2 or more substances, and that is definitely a mixture with all those different components in there. So what is in the air you breathe? So in a comparison of air that's inhaled compared to exhaled, the composition of inhaled air is what we saw basically in the last slide, is that it's 78% nitrogen, 21% oxygen, then there's some other gases, including air pollutants at times. Okay. So the air pollutants are in a very low concentration. And so though it does concern us, we'll talk about ways to prevent your exposure to air pollutants. So when you inhale air, you're inhaling, the goal is to get oxygen. And when you're exhaling, like I said, the nitrogen doesn't do anything. You don't use it. It just basically passes in and out. But there's less O2. This is 21 compared to 16. And there is more CO2. So this is 0.04 that you inhale, and then you exhale 4%. Okay, everything else is, the argon's the same, the water should be basically the same. So your body uses oxygen in human metabolism. It's used for chemical reactions to break down sugars, and carbon dioxide is generated from human metabolism. So you breathe in oxygen and you exhale carbon dioxide. So what else is in a breath though? Okay, it kind of depends on what else is in the air. So nitrogen and oxygen are 99%, and it's the less than 1%, the other gases, that includes those air pollutants. Less than 1% air pollutants and other gases. And so the air pollutants are variable. Okay, so the ideal atmosphere for us to breathe is the one without the air pollutants. The ideal atmosphere has the 78% nitrogen and 21% oxygen. But sometimes the air pollutants take over and there's more. Okay, these images show what China looks like on the same in Beijing, China, on different days. This is not because it's raining or it's the middle of the night. It is due to air pollution, mainly over there nitrogen oxides. And we'll talk about how those are generated here as well in the United States. But you can have perfectly clear air, and that is minus the air pollutants. Okay, so at times humans could use more oxygen, more O2. That's the idea of having an oxygen when you're attached to oxygen in a hospital. But oxygen basically increased. If we were to have like an atmosphere with increased oxygen, that would actually cause problems and lead to more combustion and fires, and we definitely don't want that. So we'll continue in lecture and work on this worksheet.